Hi, my name is Tovar, and today I'll be talking to you about staying alive, predicting shelter-in-place orders using Twitter sentiment analysis. So you may have heard about the coronavirus. It's been in the news a lot lately, and it now affects everyone's day-to-day lives. So I'll be talking about the coronavirus in relation to Texas, and more specifically on a county level. First, I just want to give some background. So since the outbreak of the coronavirus, the governor has issued two orders. He has issued a disaster declaration for the state and a stay safe order for the state. Counties have also taken actions of their own by issuing these orders along with shelter-in-place orders of their own on a county-to-county basis. So I wanted to build a model that predicts whether or not there is a shelter-in-place order or a stay-at-home order on any given day between the months of February and March, because that's all I really have data for at the moment. So what I have here, I created my model using GBM. And so I had a data sampler because in my initial data scraping, I had to collect the tweets for Texas on a day-to-day or on a city level, and then map these cities to counties. So what I found was that cities sometimes belong to multiple counties, so I had to randomly sample this data and assign tweets to just one county it may have lived in. So after I have my data sampler, I then aggregate this data on a county and date level. So a row in this matrix here would represent a given day in a given county, and it would have disaster declarations and shelter-in-place or stay-at-home order declarations attached to it. So after I do the sample aggregation, I then move on to hyperparameter tuning, in which I tune 3 parameters. I tune the number of leaves, the number of estimators, and the learning rate. From here, I move on to cross-validation, where I do k-fold equal to 10. So my model actually turned out to do pretty good. The best model accuracy score I got was a 0.9725. And so here I just show some of the feature importances. As you can see, column 2 seems to be the most important column, and column 2 is represented by disaster declarations. Here you can see my rock curve, in which it shows that my model does relatively well. And then I just wanted to look at the tree that GBM was building. So as you can see here, column 2 plays a crucial role in how this tree makes decisions and how the rest of it is made. And so really that's all. I built this model, and right now it's just for stay-at-home orders. I know the title says shelter-in-place, but it predicts whether or not there is a shelter-in-place order in a given county on a given day, and I plan on going on to do shelter-in-place orders as well. I also want to make this model multilingual, but because of timing constraints and really funding issues, because I found the library I was wanting to use depends on the Google API, I have not been able to do that this time. But those are just future plans to continue with this project going forward. But that's really it. Thank you for watching.